Okay, it's Steve here with another scintillating Topic 12 video for you. What I want to do in this video is take you through Activity 12-2. It's called birth weights. There's a fair bit going on in the video. So first of all, we'll be looking at calculating proportions and percentiles in the normal distribution by hand, and then we'll also use an online applet to do it as well. Okay, so there's that split. Okay, and we'll be doing things, calculating proportions the way we were in Activity 12-1. So we'll start with kind of a review of that idea. But then we'll also be doing some more complicated, perhaps, or less obvious calculations in the second half of the problem. So I want to split this video up into two parts. Okay, and so the first part, I want to take you through steps A through E on the activity, and focus on a little bit of review of what we did in 12-1, and then using technology, using the online applet, okay, to calculate percentiles. All right, so that's how it'll go. And then the second video, we'll get into some of the more complex calculations. Okay. All right, so here's Activity 12-2. It says that the birth weights of babies in the U.S. can be modeled by a normal distribution with mean 3,300 grams and standard deviation 570 grams. Okay, so first thing that should jump into your mind when you read that, when you hear those words, the word normal distribution, is you should be thinking of that symmetric and mound shape, right? Okay. So then we're also given the additional information that babies weighing less than 2,500 grams are considered to be of low birth weight. Okay, so here's what we're going to work on. It says label the picture. Okay, and again, there's our symmetric mound-shaped distribution. And then it says shade the region corresponding to the probability that a randomly selected baby will have low birth weight. All right. Okay, and then in parts B through E, it says find the likelihood of a randomly chosen baby having low birth weight. Okay, and we'll do it twice, first using Table 2 and then using the normal probability calculator applet from Rossman and Chance. Okay. Now it's notable that we can calculate these proportions even though we don't know the size of the population, right? The point is that the normal distribution, the area under the normal distribution includes 100% of the observations, and the use of Table 2 gives us the proportions in these different areas, in these different regions. Okay. All right. Okay, so let's do part one. Let's label the picture and then shade the region corresponding to the probability that a randomly selected baby will have low birth weight. Okay, so I'll switch over. Okay, so our mean is 3,300 grams. So that's the center of our distribution, right? Okay, and I should give myself a good label here. I'll say birth weight in grams. All right, great. All right, and then if I want to get a good label, then I have to use the standard deviation here. Okay, my standard deviation is 570, and remember what that means geometrically, right? The standard deviation, one standard deviation is where your normal curve changes concavity from concave down to concave up. So I'm looking at, somewhere around here. It's concave down, and then it becomes concave up, bent up. All right, so that's one standard deviation. And I can go either direction. Not looking for perfection here, but just so we ballpark it pretty good. All right, and then that's one standard deviation, so that corresponds to a birth weight of 3,870, right? And then if I go a second standard deviation, the same distance up again, that's going to be 570 more, so that's going to be 4,440. Okay, and if I went a third standard deviation, then looking at my cheat sheet, 5,010. Okay, at least roughly. All right. Okay, and now going back the other way, going a standard deviation. Okay, I subtract 570, so that's going to be 2,730. And if I go down 2 standard deviations, so I'll go a second standard deviation down, that's 2,160. And my third standard deviation down is 1,590. Okay? So then I've got a pretty solid picture of what I'm looking at. All right. Now it says shade the region corresponding to the probability that a randomly selected baby will have low birth weight. Right. We said low birth weight is 2,500 grams. Okay. So good. So we got it. We got things labeled pretty well here. I'm going to go to at least roughly where 2,500 grams is. Not perfect, I know. Okay. And that area that I've shaded, right, that corresponds to the proportion of babies that have low birth weight, right? Okay, awesome. All right, now our job is to calculate that, right? So it says we want to find the likelihood that a randomly chosen baby has low birth weight. Now, just looking at the picture, right? So 100% of the observations correspond to all the area under the whole distribution, right? Of the whole normal, standard normal curve, right? And this is the proportion corresponding to low birth weight babies. So you can see, you can expect that that proportion is going to be fairly low, right? Okay. All right. And now what we can do is we can use table 2 or technology to figure out what that proportion is. Okay. So let's do it by hand first. Right? Remember how we did that in activity 12-2? Okay. We can find the z-score for the 2,500, a weight of 2,500, and then we can use table 2. Right? Remember that table 2 tells us the proportion of observations below a certain z-score. That's exactly what we want here. All right, so first let's find our z-score. All right, so remember to find your z-score, I'm going to use a thicker marker here. Z is our observation minus our mean divided by our standard deviation. Right, so my observation is 2,500. My mean is 3,300. My standard deviation is 570. Okay. Now, if you're 2,500 grams, then that means you're 800 grams below the mean. And if I carry out that division, let's see, got my calculator here. Negative 800 divided by 570 gives me about negative 1.40351. Okay. All right. So that's my z-score, about negative 1.40. Remember what that means? Okay. That has a very specific determination, right? The negative means we're below the mean, and we're 1.4 standard deviations below the mean. Okay. So that's somewhat significantly below the mean. All right. So then we are looking for the proportion, remember our notation, the proportion of baby weights, okay, if I call that X, no, let's call it something else. Let's say our weight is less than 2,500, okay, that's going to be at least approximately the same as the probability of getting a z-score less than negative 1.40, okay. I'm rounding to the 100th, because remember our table 2 is only good to the 100th value, all right? And then we go to table 2, all right? Here's my table 2. This is not a great shot, so I'm going to switch back to my other camera. All right, there we go. Let's find it. Okay, so we're looking for a z-score of negative 1.40. Remember that our table 2 gives us area to the left, right? So, and that's exactly what we want, okay, because we're looking for weights less than 2,500. Oh, and here we go, negative 1.4, and we're looking at negative 1.40, so we're looking at the first entry here, so it's 0.0808. Okay, so that tells us that if you randomly grab a baby, a newborn, then there's about an 8% chance that it's of low birth weight, right? Weight less than 2,500 grams. Awesome. Or said differently, the proportion of all babies born that have low birth weight is about 8%. Okay, and there we go. We've done it by hand. Okay. Now I want to show you how we can do it using some online technology. All right, so I'm going to switch back to my my computer. Okay, and now on Canvas, I'm on our Canvas homepage. I'm going to take our link to Rossman and Chance, their list of applets. Okay, now open that window. All right, and then what we're looking for is the normal probability calculator. All right, and here it is. Okay, so what the normal probability calculator does, if we understand how to use it, is it just automates a lot of this. Okay, so my variable, I'm going to call it birth weight. All right, and you can see that changed the picture here. And now I have to tell it, it starts by assuming that the mean is 0 and the standard deviation is 1. I have to tell it that the mean is 3,300 grams and the standard deviation is 570. And the picture disappeared, so I better scale it to fit. And now it's drawn the same picture that we had, right? Okay. And now I can just ask it the question that I'm interested in, right? I'm wondering, okay, I'm going to ask you, here's where I'm going to ask the question. I want to know for what values is x, the variable, the birth weight, for what values, or not for what values, is how likely is it to have an x value, a birth weight less than 2,500. Okay, and it says, all right, if you do that, if you want to know what proportion have a weight less than 2,500 grams, it shades the area for us. It tells us that's corresponding to a z-score of negative 1.404 roughly, and the probability is 0.0802. Okay, it's a more exact answer. It's a better answer than what we got from table 2, but you do need the technology to do it for you. Okay, so again, we get this confirmation that about 8% of all babies born have low birth weight. Great. So I'll continue this this discussion of activity 12-2 in the next video.